Morning class. Um, okay. Okay, that's fine yan. Okay, so let's proceed to our activity for today. So let us have first an activity before we proceed to our discussion. So in today's activity, we're going to use an application called GeoGebra. So we're going to try to form triangles. So our activity is entitled as, okay, you've got triangles. So given set of lengths, we're going to try to form triangles. Okay, so I'll be sharing with you the application, and I'll give you first the set of lengths. And afterwards, you're going to give me your own example. So, let's say we have here, okay, I'll share first my screen. Okay, so let's say we have here the side of the triangles with the lengths of 4, 6, and 7. Okay, so we have here the length of the sides of a triangle with the length of 7. And let's try to find out if we are able to form a triangle using these sides. Okay, so we have 6, 7, and 4. And is it visible to you? My screen is visible to you. Do you think that we have formed a triangle using this set of lengths? Yes or no? Do you think that we have formed a triangle? Okay, type yes or no in the chat box if you think that we have formed a triangle. Yes or no? With the given sides of 6, 4, and 7. Do you think that we have formed a triangle? Okay, so yes. Okay, thank you. So we have formed a triangle using this given set of lengths. How about if we have here 3, 5, and 10? Okay, so if we have 3, 5, and 10, let's see if we can form a triangle. Okay, so let us first connect the endpoints. And this length gives us this image, or it formed this figure. So do you think that we have formed a triangle with the given side of 3, 5, and 10? Yes or no? Type in the chat box. Do you think that we have formed a triangle, class? Anyone who wants to answer? Angela, do you think that we have formed a triangle using the lengths 3, 5, and 10? Yes or no? Yes. How about the others? Do you think that we have formed a triangle? Do you think that this figure is a representation of a triangle? No. Okay. So, in this given set of lengths, we are not able to form a triangle. So, as you can see, the endpoints of the um, the line with the length of 5 and 3 did not meet. So, we are not able to form a triangle. Now, it's your turn, okay? So, give me 3 numbers, not more than 10. So let's see if we can form a triangle using your own example. Let's try to have, okay, John. John, please give me 3 numbers, not more than 10. And let's try if we can form a triangle using those numbers. Okay, so type the numbers that you want. Three numbers that are not more than 10. Okay, so give me your number. John Gabriel. Okay, John, are you there? Are you still there? Type the number. Type the three numbers that you want us to form. Okay, any number. Sige, it's fine. Any number. Any number not more than 10. Three numbers. 4, 6, and 9. So let's see if we have 4, 6, and 9, if we can form a triangle. We have 4, 6, and 9. Okay. So this gives us the figure of, oops. Okay. So do you think that we have formed a triangle with the given lengths of 4, 6, and 9? Yes or no? Yes. Okay. Another last set of numbers. Selwyn, did I pronounce it correctly? Selwyn, can you give me three numbers? Three numbers not more than 10. Let's try if we can form a triangle. Okay, type your numbers. Type the numbers that you want. 5, 7, and 9. Okay, so let's see. We have 5, 7, and 9. Okay, so in this figure, in this given set of lengths, let us try to form a triangle. Let's try if the endpoints will meet. Okay. So do you think that we have formed a triangle using the sets of 5, 7, and 9? Yes or no? Okay, type your answer. Yes or no? Did we form a triangle using these sides of 5, 7, and 9? Okay, type your answer, class. Yes or no? Yes. Okay, so we have formed a triangle using the given set of numbers. But we have an example earlier that we are not able to form a triangle. So what might be wrong with that given set of numbers? Why are some numbers can be formed as a triangle and some are not? Okay, so we're going to find out in our today's lesson. Okay, so I'll be sharing with you the presentation. Okay, but before that, let us recall if we are able to make triangles using the lengths of side, let us now recall the types of triangle according to their sides. Okay, so we have here the first type of triangle, the triangle A, B, and C, that you may notice in this figure that we have two two sides that are equal to each other or congruent. So the side AB, line AB and line CB or BC are congruent to each other, meaning to say that they have the same lengths. And if a triangle has two equal sides, this is called as the isosceles triangle. Next, Another type of triangle. Now, in this illustration, it shows that the triangle has no equal sides. Okay? No equal sides. And if a triangle has no equal sides, it is called as the scalene triangle. And lastly, what if a triangle has three equal sides, or all of the sides of the triangle are congruent? It is now called as the equilateral triangle. So from our first activity, we have formed a triangle using the measurement of their sides. And some are not formed in the measurements. So how does this happen? So we have here the triangle inequality theorem. So what does triangle inequality theorem says? It says that the sum of any two sides of the triangle must be greater than the third side. Okay? For example, we have here the sides of the triangle 6, 7, and 8. So this is the value of the sides of the triangle. And it says here in the statement that the sum of any two sides must be greater than the third side. Okay, so let us add. What if we have here as the two sides with the value of 6 and 7, for example. So the first two sides are 6 and 7. And if it is added to each other, its value is greater than 8, which is the third side. So this satisfies the equation. It is correct. How about if 7 plus 8? Another two sides from the triangle. So now the third side will be 6. So if we added 7 to 8, we have 15, and 15 is greater than 6. So another point that satisfies the given statement. And lastly, we have the side of 6 and 8. And when we add 6 and 8, its answer is greater than 7, meaning to say the set of length, or this set of length of the triangle will make a triangle, will help us form a triangle because it satisfies the statement of triangle inequality theorem. Let us have another example. What if the sides of the triangle are 2, 5, and 7? Okay, so let's find out. If we add 5 plus 7, what is the answer if we add 5 plus 7? Type in the chat box. 5 plus 7 is equal to, okay, let's see if you're still there and you're still listening. What is the answer for 5 plus 7? Yes, 5 plus 7 makes 12. So, do you agree that 12 is greater than 2? Yes, 12 is greater than 2. So, the first two sides satisfies the statement. How about if we have 2 plus 7? So, 2 plus 7, which makes 9, is also greater than 5. And 5 will be our third side now because we have 2 and 7 as the first two sides. So that's correct. It also satisfies the statement. How about if we have 2 plus 5? So meaning to say that 2 plus 5 is also equivalent to 7. So they are equal to each other. That this time, this does not satisfy the given statement because the statement says that the sum of the two sides should be greater than the third side. Okay, so this does not satisfy the statement. And another example, we have 9, 4, and 3. So let us try to add the first two sides again. We have 4 and 9 as the first two sides, and 3 will be the third side. So it is true that 4 and 9 is greater than 3. How about 3 plus 9? 3 plus 9 makes 12. That is also greater than 4. So it is correct. But if we have 4 plus 3, the answer is 7. And this does not satisfy the given statement. So why do you think so? Why do you think so that 4 plus 3 does not satisfy the given statement? Because 4 plus 3 is less than the third side, which is 9. So meaning to say we are not able to form a triangle using these sides of triangle. Okay? So do you have any questions or clarification regarding these examples? Okay, so you can turn on your mic or you can chat if you have any questions, because if none, we're going to have an activity. No questions? Okay, so let us have an activity first. Okay, so we're going to use the website kahoot.com. Okay, so kahoot.com. Check your chat box. We're going to use kahoot.com, and all you have to do is to enter the game pin so that um so that you can participate in our activity. Okay, so I'll be sharing with you the game pin. Here is the game pin. Okay. You may now join the you may now join. I will also type in the chat box the game pin 3108154. Okay. So enter the game pin so with that we can start the activity. Okay, I'm inviting you all to participate in this activity. And let us see how well do you understand the concept of triangle inequality theorem. Okay, still waiting for the players. You don't need to sign up. Just enter the game pin. Okay, so you have to just click the play in the upper right corner of the website and then enter the game pin. Okay, Racelis is in. You can also use your nickname. Okay, you have two participants, Yana, Amora, Yana, Sylvine, and Racelis. We have four. How about the others? We're still waiting for four more students. Okay, so join now. Cassandra. Nicole is in. We have now 5 participants. Sophia, we have 7. And last student, we have 7 students. Who else is not in the game? Sim Daryl. Okay. Dax is in Daxin Daryl. 1, 2, 3, 4, 5, 6, 7 students. Daxin Daryl, Pionelia is in. How about the other last student? Mhm. Any other participants? Okay, so let's start. May hindi pa ba kasali? Okay, so tell me, if meron pa kayong kaklase na hindi pa kasali. Okay na. Okay, thank you very much. So let us start. Triangle inequalities. So for our first question, you want to build a triangle-shaped garden. Which set of wood lengths would you choose? Okay, so we have 4 correct answers. Okay, I forgot to tell you that you only have 20 seconds to answer each question. And the last question requires 1 minute. Okay? Triangle inequality theorem states that the sum of the lengths of any two sides of the triangle must be what? The sum of the two sides must be okay, must be greater than the length of the third side. So, who's the leading? We have Daryl and Kate. Bawi pa yan. Third question, which of the following could be the length of a triangle? Okay, for you to be able to form a triangle, what should be the length? Okay, the correct answer is 2, 7, and 8. So, wala na dagdag. Masyadong mabilis ang ano, timer. Okay, and last, the sum of the measures of the angles in a triangle is always equal to all the included angles in a triangle. When added, what must be the answer? Okay, so 180 degrees. Okay, so always remember class that in a triangle, all the included angles, when you add their value, it is always equal to 180 degrees, okay? So, before we proceed to our next question and the final question, um, always remember that for you to be able to make a triangle, what it is said in the triangle inequality theorem that the two sides when added must be greater than the third side, right? Okay? So, last question. Oh, Sophia is leading now. Napalitan. Last question. Which set of sides would not form a triangle? Ano kaya dyan ang hindi makakapag-form ng triangle? Okay, so try to add the sides and let's see. Okay, 2 more answers. 1 more answer, hinihintay. Okay. So the correct answer is none of the above. So bakit? Kasi pag inad po natin any side of this triangle, it will always be greater than the third side, di ba? So lahat po ng given, all of the given answers satisfy the statement of the triangle inequality theorem. So let's find out sino ang ating winner for the activity. For the third place, we have Sophia. And, wow, si Angela. Second. And congratulations to Nicole. Yan, si Nicole ang ating first placer. And thank you so much to everyone who participated. Okay, so now let us proceed with our um, discussion. Okay, so let me share with you again my PowerPoint presentation. Okay, we're done with the activity. Okay, so we have here theorems that prove the triangle inequality does exist. First, we have the Isosceles Triangle theorem, and it says that if two sides of a triangle are congruent, if they have the same side, if two sides of the triangle has the same value, then the angles, the included angles opposite them, opposite the sides are also congruent. Let us have here, for example, triangle A, B, and C. And they have included angles of also A, B, and C. So here is an example wherein a triangle has its value. Let's say that the first figure triangle A, B, and C has the length of the side of 20 for line AB and 20 again for line AC. And for line BC, we have the value of 15 as its length. How about its included angles? Okay, so I have mentioned earlier that for every triangle, the included angles when add up should be equal to 180 degrees. So we have here 72 as angle B, 36 degrees as angle A, and 72 degrees as angle C. So when we add all of this value, we'll come up with a total of 180 degrees. So, and when we added this line, okay, this line serves as an auxiliary figure because we're trying to prove if these two sides will be congruent to each other. So if we are to put this auxiliary figure, this makes this triangle as two triangles, right? So suppose that this is the endpoint of from A, the endpoint will be M, okay? So we have formed triangle A, B, M, and triangle A, C, M. So there are two triangles, okay? And its value now is 90 degrees. So below 36 degrees, this in this part is 90 degrees. And it is also congruent to the other side, right? Okay, so let's check. In this second figure, I want you to give me the value of B. If in isosceles triangle theorem, it is said that the opposite angle is also congruent. Okay, so we have 62 as the value of angle A and 59 as the value of angle C. What do you think will be the value of angle B? So type your answer in the chat box. Okay. Okay. So type your answer. What should be the value of B for us to satisfy this statement of the isosceles triangle? If in the first figure we have 72 degrees for B and C because they are congruent, what should be the value of B here if angle C is 59 degrees? Type your answer or you can turn on your mic. What is the value of angle B? Okay, so any idea? What is the value of angle B? Type your answer. Okay, I'm just going to ask if you don't like to type your answer. Sophia, what do you think is the value of angle B? Okay, Sophia, what do you think is the value of angle B? Okay, compare this. Yeah, correct. It is 59 and 59 added to 59 and 62 will give us 180 degrees. So that's correct. The value of B is 59 because they are congruent to each other or they have the same value. Next, okay. This time we have the theorem 3.7 and it says here that if two angles of a triangle are congruent, meaning to say we have B and C as the congruent angles, then the side opposite them are congruent. So the side opposite them is congruent. So which side? The side of AB and line AC. So let's see. We have here another example. So we have 80, 50, and 50 as the value of their angles, and the side is 65 that is congruent. Line AB is 65 that is congruent to line AC. So we have 65 and 65. How about in this second figure? If line AB is 38 and it is said that it is congruent to line AC, what should be the value of line AC? Type your answer, Maria Cassandra. What is the value of line AC if line AB is 38? Okay, so correct, it is 38 because they are congruent to each other. So in a triangle, if we have the congruent sides, their included angles are also congruent. Okay, next example. Next theorem. Okay, so we have here a figure of a triangle that has an extended line. Okay, so we have here the triangle 1, 2, and 3, which has the value of its included angle as 60 degrees. Okay, 60 degrees each. Okay, so again, if we add this, all the included angles will give us 180 degrees. And what about this theorem? So we have here the exterior angle theorem. So you may notice in the figure that we have here an exterior angle, and the exterior angle is angle 4 because it is already outside the triangle or the figure 1, 2, 3. So that is the exterior angle. How about angle 1 and 2? They are called as the remote interior angles because they are opposite our exterior angle, which is 4. Now, I want you to notice this, that if angles 1, 2, and 3 has a total of 180 degrees, in angle 3 and 4, okay, so this gives us an angle of 180 degrees. Okay, so if you have a protractor, you may notice that the this gives us 180 degrees. So what if the value of the angle 3 is 60, and this should form 180 degrees. So what you need to do is to add 60 to 120 in order for you to form 180 degrees. So in this given, we need to prove that angle 4 is greater than angle 1 and angle 2. So how are we going to prove that? Okay, so simply as what we have done or what I have mentioned earlier, if this if angle 3 and angle 4 has the sum of 180 degrees, all you have to do is to subtract 180 from the given degrees. If the given is 3, then you have to subtract its value to 180. And if the given is 4, you have to also to subtract it to 180. For example, here we have 65, 65, and 50. So this included angles gives us 180. How about the value of angle 3 and 4? Okay, so if the value of angle 3 is 50, and this makes 180 degrees, meaning to say that the value of 4 is 130 degrees. When added up, it gives us 180 degrees. So let's have another example. Here, if we have 52 degrees for this second angle or angle 2, and 53 for angle 1, and 75 for angle 3, okay, let's check if we add this. This gives us 180 degrees. How will you find out the value of angle 4? So what do you think is the value of angle 4? Anyone would like to answer? Okay, correct. The value of angle 4 is 105. So if we add 105 to 75 degrees, it makes 180 degrees. That's correct. Next, we have here theorem 3.9, and it says that if one side of a triangle is longer than the other side, also which side is longer? So we have line MN that is longer, that is said to be longer than line AN. So how did that happen? Okay, so we have to prove that that angles MAN is greater than AME. Okay, so let us have an example. Okay, so in this figure, we have the value of the sides and the included angles in the triangle. So this triangle is just tilted. That's why it is formed as like this. Okay, so it is said that line MN is greater than AN because we have here the value of 80 as line MN, and the value of line AN is 68 degrees. So what makes it greater than what makes line MN greater than line AN? Because, okay, we added another auxiliary figure here, and the degrees which forms another triangle for A and E. So this is another triangle that is included in the whole part of the triangle. That's why line MN is greater than line AN. Same as with this example. So I want you to find the missing value or the missing value of um, angle M. Okay, so I'll repeat. If the values of when you add the values of the included angle, it should always the sum should always be 180 degrees. So if we have the value of 52 for angle N and 76 to angle A, what should be the value of angle M? Okay, so type your answer. If N is 52 degrees and 76 for angle A, what should be the value of angle M? Okay, so what should be the value? 52? Okay, are you sure that is 52? Yes, that's correct. It is 52. Okay, and this also satisfies the isosceles triangle theorem, which says that uh, the opposite has has same values or congruent to each other. So we have 52 and 76, that makes it 180 degrees. So that's correct. Next, in theorem 3.10, it is somehow the same as 3.9. Um, Only then we have to prove here is that line MN is line the given is MAN is greater than AME. So just like the explanation from 3.9, it is greater than line MN is greater than line AN, or triangle MAN is greater than triangle ANE because triangle ANE is just formed using the auxiliary figure or this figure. So how do we check if this is also a triangle? So if we have included an auxiliary figure here, this gives us 90 degrees. Okay, so this gives us a triangle, right? And if we added the value of its included angle, it also forms 180 degrees. So meaning to say it is a triangle inside a triangle. Okay? Next, we have theorem 3.11, and this is also just like the concept of our first activity. So the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So we have here an example of triangle XYZ. So you may notice that they have the values of 35 for line XY and 62 for line YZ and 48 for XZ. Okay, so these values, when added up, let's say we have line XY plus YZ, its total or the sum is greater than 48. Same goes with XZ that is added to YZ, it is also greater than XY. So let us have an example. Okay. So I want you to give me a number that will satisfy the statement. Here we have the value of XZ as 76 here and YZ as 84. So if we added this number, the side of XY should be less than the value of 76 and 84. So what do you think should be, or what do you think is included in here? What is the length of the side? So type your answer. What do you think is the value of line XY? Let's have John Gabriel. John Gabriel, what do you think is the value of XY? Okay. A number that will satisfy this given statement. What do you think is the value of XY? Okay, so anyone who would like to help John Gabriel? How about Sophia Loris? What do you think is the value of XY? Anyone would like to answer? Or anyone would like to guess? Okay. What should be the answer? Or what number might satisfy the given statement. What is the number that when added to 84 will give us the sum of greater than 76? And what number should be added to 76 that gives us the value greater than 84? Okay. Anyone? Yana, what do you think is the value? Or what do you think might be the value? 265, 90. Okay, let's see. Okay, if 265, if 265 is added to 76, then obviously 341 is greater than 84. That's correct. And if 265 is added to 84, the answer is 349, so it is also greater than 76. So 265 might be, or it is possible that the value of x and line xy is 265. How about 90? Let's say that 90 is added to 84 and the answer is 174. 174 is greater than 76. That is correct. How about if 90 is added to 76? It is greater than 166. So that is also correct. That is greater than 84. So, okay. Okay, thank you so much for your answer. So, those answers might be the possible uh, possible value of xy. Thank you. Okay, next we have theorem 3.12. So, theorem 3.12 is a hinge theorem. So, it says here that, for example, we have two triangles. And these two triangles have the same value of the sides. Okay, so you may notice that the first side is 30, line CM is 30, also with line AV, they are both 30. How about if we have line CX and line AN? They have both the value of 45, so they are also congruent. But in this case, the third side, which is MX and VM, has different values because of the included angles 75 degrees and 60 degrees. So in Hinge Theorem, we have two triangles that has congruent two sides, but the length of their longer sides are not congruent because of the included angles. So that is what Hinge Theorem tells us. Okay, let's have another example. Okay, so if we have here the triangle CMX again and AVN, wherein triangle CMX has 42 degrees, okay, and their sides 25, 40, and 58. How about triangle AVN? It has also 25, the side of 25 and 40, but the included angle is 30 degrees. So what might be the value of line VN? Is it longer than 58 or shorter than 58? Type your answer. Okay, what might be the value of line VN? Okay, if we have 58 for MX and it has 42 degrees, what if we have 30 degrees? Does the third side should be longer or smaller or shorter? Longer or shorter than the first triangle? Okay, type your answer. Shorter or longer than the first triangle? Shorter. Okay. Are you sure? Okay. Yes, you should be sure. Yes, correct. That is shorter, Maria Cassandra. Okay. The line VN is shorter than MX because its angle is 30 degrees. So the opening of this triangle is shorter than triangle CMX. So that's correct. So that is what Hinge theorem is trying to tell us. Like this one, for example, this alligator. Okay, so the opening of the mouth, the length of the mouth is the same, but the opening is of the other is shorter, meaning to say it has a shorter value, it has a lesser value of its angle. While if the opening is bigger, meaning to say that the value of its angle is bigger than the first. Okay, so that is the Hinge theorem. So when they are put together, this is the figure that will be formed. The two triangles will look like this. Okay, so our last theorem, or the theorem 3.13, this one is included in your book, and I believe that Sir Neil has sent you for our final activity. What you're going to do is to prove the Hinge theorem. Okay, so do you have any questions or any clarifications? You can turn on your microphone, or you can type your questions. If none, I'll be ending this lesson with a quote from Aristotle. And it says here that the worst form of inequality is to try to make unequal things equal. So think of this. So I can say that this quote is trying to tell us that people who have disadvantage, who, who is in a situation that is in disadvantage, should be given a consideration. So we give considerations for those who are in need before we compare them to people who are in better position. Okay, so that's it for our lesson for today. And thank you so much for your participation in our activities, and thank you for um, answering my questions. Let us have our closing prayer. Okay, let us. Uh, who lead the opening prayer? Okay, Sophia, can you please lead the closing prayer? Oh, wala ka nga palang mic. How about Selwyn? Okay, Selwyn, please lead our closing prayer.
In the name of the Father, the Son, and the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit, as it was in the beginning, is now, and ever shall be, world without end. Amen. O my Jesus, forgive us our sins, save us from fires of hell, and lead all souls to heaven.